This videotape deals with multiplication and division of radical expressions. If you remember, when we wanted to multiply polynomials, our basic rule was the distributive law. And now that we want to multiply radical expressions, once again we will be using the distributive law a lot. Now I want to recall how we multiplied, for example, x times x minus 3. The distributive law tells us that it's going to be x times x, which is x squared, x times minus 3, which is minus 3x. Now, if it's the square root of 2 times the square root of 2 minus 3, once again, we will be using the distributive law. The square root of 2 times the square root of 2. Okay, and the square root of 2 times minus 3, or minus 3 times the square root of 2. Now, the square root of 2 times the square root of 2 is just 2. Okay, the square root of a number times the square root of the same number, that gives you just the number itself. Okay, 2 minus 3 times the square root of 2. And this is as far as we go. Don't confuse this with, say, 2 the square root of 2 minus 3 the square root of 2. Here you want to, say, combine two terms that involve the same radicals, so you combine what's outside the radical, 2 minus 3 the square root of 2, or minus 1 times the square root of 2. Okay, this is not what we have here. This term does not have a radical. This one does. They cannot be combined any further. Okay, this is not 2 the square root of 2 minus 3 the square root of 2, but just 2 take away 3 the square root of 2. Okay, so the answer in this case is that. Okay, let's try another problem. The square root of 3 times 4 the square root of 3 plus 2 the square root of 5 minus 7. Once again, we're going to be using the distributive law. It'll be the square root of 3 times this, plus the square root of 3 times that, plus the square root of 3 times that. Okay, so we'll get 4 times the square root of 3 times the square root of 3, plus 2 times the square root of 5 times the square root of 3, and then plus minus 7 times the square root of 3. Now, 4 times 3, this will be 12. The square root of 3 times the square root of 3, that's 3. 4 times 3 gives you 12. This is plus now 2 times the square root of 15 minus 7 times the square root of 3. This is our answer. Okay, I got the square root of 15. If you remember, the square root of 5 times the square root of 3 is the square root of 15. The square root of a product is equal to the product of the square roots of the factors, and we might use that to say the square root of 15 is the square root of 5 times the square root of 3, but if we have this, we can also go back the other way. Okay, and here we have the answer, 12 plus 2 times the square root of 15 minus 7 times the square root of 3. Okay, now let's say we want to multiply the square root of x plus 5 times the square root of x plus 2. We will assume that x and all variables which occur in this videotape are positive real numbers. Okay, we are multiplying binomials. Okay, and the best way to do that would be to use the FOIL method. That is, you multiply the first terms, then the outer terms, then the inner terms, and then the last terms. And you add them all together. Okay, first terms. Square root of x times the square root of x. Then the outer terms. The square root of x times 2. Then the inner terms, the square root of x times 5. And then the last terms, 5 times 2, giving you the 10. Now, the square root of x times the square root of x is just x. Okay, plus, now 2 the square root of x and 5 the square root of x, these terms can be combined. We have the same quantities under the radical. We have 7 the square root of x plus 10. So x plus 7 times the square root of x plus 10. Okay, now let's work out the square root of 5 minus the square root of 3 squared. Okay, now some people looking at this feel that, well, you should be able to distribute that 2, that square, across this and get 5 minus 3 or 2. That's not the case. Okay, this is not equal to 5 minus 3 or 2. You can't square it out that way. Okay, the square root of 5 minus the square root of 3 squared means the square root of 5 minus the square root of 3 times the square root of 5 minus the square root of 3. It's this expression squared. That is this times itself. Okay, so we're talking about multiplying two binomials, and we're going to use the FOIL method. Again, the first terms gives you the square root of 5 times the square root of 5. The outer terms, you have square root of 5 and minus the square root of 3, so minus the square root of 3 times the square root of 5. The inner terms, minus the square root of 3 times the square root of 5. And the last terms, minus the square root of 3 times minus the square root of 3, minus times a minus, so that's plus the square root of 3 times the square root of 3, giving us, now, the square root of 5 times the square root of 5, that's just 5, minus the square root of 15 here, minus the square root of 15 again, plus 3. The square root of 3 times the square root of 3, and we can combine. We have 5 plus 3 giving us 8. Minus the square root of 15 minus the square root of 15 gives us minus 2 times the square root of 15. Okay, the answer is not 5 minus 3 or 2, but rather 8 minus 2 times the square root of 15. There is a problem that I could give you for which the answer would come out to be 5 minus 3, which would look a little bit like this. Instead of multiplying the square root of 5 minus the square root of 3 times the square root of 5 minus the square root of 3, what would happen if we multiplied the square root of 5 minus the square root of 3 times the square root of 5 plus the square root of 3? Okay, there's a difference here from what we had before. Here we were multiplying the square root of 5 minus the square root of 3 times the square root of 5 minus the square root of 3. Now, the square root of 5 minus the square root of 3 times the square root of 5 plus the square root of 3. So I've changed this sign here. Okay, let's once again do this by the FOIL method. First, outer, inner, last. For first, we have the square root of 5 times the square root of 5. For outer, we have the plus the square root of 3 times the square root of 5. For inner, minus the square root of 3 times the square root of 5. And for last, minus the square root of 3 times the square root of 3. And what we get here is square root of 5 times the square root of 5, that's 5, plus the square root of 3 times the square root of 5, or plus the square root of 15, will cancel out minus the square root of 15, which appears right after it, and then minus the square root of 3 times the square root of 3, which is 3. These two knock each other out. We do get 5 minus 3, or 2, for an answer. Okay, what we had here really was an example of a minus b times a plus b. The difference in two numbers times the sum of the two numbers, which you might recall, gives you a squared minus b squared, the difference in two squares. Okay, if you knew that before you started, you wouldn't have to go through all of this. You have here the difference in two numbers, the sum of the two numbers. So what you wind up with is the first number squared minus the second number squared. 5 minus 3, or 2. Okay? This is all right. Don't confuse that, however, with this. Here you had the difference times the difference, and this had to be multiplied out the long way, and we did not get 5 minus 3. Okay, you cannot just distribute this power all the way through. It must be done the long way. Okay, let me give you another example. Why don't you try this one on your own? You can shut off the machine and turn it back on when you're finished. Okay, we're going to use, once again, this is 2 terms times 2 terms. You can only use the FOIL method if you have a binomial times a binomial. Okay, if there were more than 2 terms or less than 2 terms in one of them, then you could not use FOIL. Okay, first, 3 the square root of x times the square root of x. Outer, 3 the square root of x times the minus 4 times 3 the square root of x. Inner, plus 2 the square root of x. Last, 2 times minus 4, that's minus 8. Now, 3 the square root of x times the square root of x, that's 3 times x. The square root of x times the square root of x is just x. Once again, x is always considered here to be a positive number. Minus 12 the square root of x plus 2 the square root of x minus 8. Giving us, after we combine these two middle terms, because they both involve the square root of x, 3x minus 12 the square root of x plus 2 the square root of x is minus 10 the square root of x minus 8. Okay, now that takes care of multiplication. Now, as we get into division, I want to recall how we rationalize denominators. Let's start with a simple example, 8 over the square root of 6. If you recall, 8 over the square root of 6 is not in what we call simplest radical form because there is a square root in the denominator. There's a radical in the denominator. Okay? The procedure for putting this into simplest radical form, which rationalizes the denominator, that is, replaces the denominator by a rational number, is to use the fundamental principle of fractions, which says it's perfectly okay to multiply the top and the bottom of a fraction by the same non-zero quantity. If you do that, you will get an equivalent fraction. Okay, and what we're going to do in this case is to multiply the top and the bottom by the square root of 6, the radical that appears in the denominator. Okay? We've multiplied top and bottom by the square root of 6, which is perfectly okay thing to do, and we have now multiplying the tops 8 times the square root of 6 over the square root of 6 times the square root of 6, that's just 6. Okay, and we're not quite finished yet because we can certainly reduce this. 8 and 6 have a factor in common. You can divide numerator and denominator by 2. 8 divided by 2 gives you 4, and 6 divided by 2 gives you 3. This is the final answer. We cannot go any further. Don't think you can then take the 3 and divide it into the 6 here. There is a difference. The 8 and the 6 were both outside of the radical. Okay, 8 6 could be reduced to 4/3. Okay, you cannot work with what's inside the radical at the same and cancel it out with things that are outside the radical. The 3 and the 6 cannot be divided together, simplified in this way. Okay, you can't put the 3 into the 6 and get 4 the square root of 2, for example. Okay, the 8 6, they were both outside the radical, you could do it. If you had two things that were inside the radical, you could also do it. For example, if I had the square root of 10 over the square root of 2. Okay, this is the square root of 10 halves, which comes out to be the square root of 5. This would be perfectly okay. This is just a separate thing. This would be okay. If two things are both under the radical, then you could just make one big fraction out of it. Okay, and if two things are both outside the radical, you can cancel and simplify. Okay, but you don't simplify, you don't cancel things inside the radical with those outside. Okay, now this was a simple problem in rationalizing the denominator because the denominator only had one term. That is the square root of 6. It's a little trickier to rationalize the denominator when there's more than one term in the denominator. Let me give you an example of rationalizing a binomial. Let's say we had 1 over the square root of 5 minus the square root of 3, and we want to rationalize the denominator. Or put it into simplest radical form. Our object is to replace this by an equivalent fraction, okay, but does not have radicals in the denominator. Now, what we did over here, since there was only one radical, is to multiply numerator and denominator by that radical. Here we can't get by on this. Okay, if you tried, for example, to, these are wrong ways to do it. wrong way. If you multiplied, say, top and bottom by the square root of 5, that wouldn't help, because that would give you on the top the square root of 5, and on the bottom, the square root of 5 times the square root of 5, when you distribute the square root of 5, the square root of 5 times the square root of 5 would give you 5, but then you also have to multiply the square root of 5 times the square root of 3, and that would give you here minus the square root of 15. So you've eliminated one of the radicals, namely the square root of 5, but you now have another one, the square root of 15. And you still have a radical in the denominator. Okay, the square root of 5 won't help. And in a similar fashion, we could show that multiplying top and bottom by the square root of 3 doesn't do anything more for us either. Because on the top now you'd have the square root of 3, and on the bottom, the square root of 3 times the square root of 5 would give you the square root of 15, and you'd have minus, now the square root of 3 times the square root of 3. That would at least get rid of the square root of 3 in the bottom, but of course you'd still have the square root of 15. So this is the wrong way to do it. You can't multiply by just the square root of 5 or the square root of 3. We're looking to multiply numerator and denominator by the same quantity so that the result is that there is no more radical in the denominator. Okay, let me show you how to do that. We're going to make use of the fact, we mentioned this a little earlier, that a minus b times a plus b is a squared minus b squared. If you remember a little earlier today, we had the square root of 5 minus the square root of 3 times the square root of 5 plus the square root of 3. And the answer came out, this was the difference in two numbers times the sum of two numbers. We got the first number squared minus the second, so we got 5 minus 3, or 2. And this is what we're going to use in rationalizing the denominator. We're going to take 1 over the square root of 5 minus the square root of 3, and we're going to multiply numerator and denominator by the same quantity, and the quantity is going to be the square root of 5 plus the square root of 3 over the square root of 5 plus the square root of 3. Okay, first of all, what we're doing is a legitimate thing to do. We are multiplying top and bottom by the same quantity, so we're going to get an equivalent fraction. Now, this has been chosen because on the top we have just 1 times this, so you just get the square root of 5 plus the square root of 3. And on the bottom, we have a minus b times a plus b, the difference in two numbers times the sum of the two numbers, just what we have over here. So we're going to wind up with the square root of 5 squared minus the square root of 3 squared. That is 5 minus 3, or 2. So we get the square root of 5 plus the square root of 3 over 2. By the way, the square root of 5 minus the square root of 3, the square root of 5 plus the square root of 3 are considered conjugates. Whereas if you think of this as a minus b, then a plus b is its conjugate. On the other hand, if the problem started with the square root of 5 plus the square root of 3, then we would use the square root of 5 minus the square root of 3, and that would be its conjugate. The trick is to think of this as either a minus b or a plus b multiplied by the conjugate so that you wind up on the bottom with a squared minus b squared, which gets rid of the square roots for you. Okay, let's try another example in rationalizing a binomial denominator. Square root of 2 over the square root of 6 plus 2. Okay, there are two terms in the denominator. One of them has a radical and the other one doesn't. Now, don't think that you can get by, say, here with multiplying the square root of 6 over the square root of 6, because what would happen is that the square root of 6 times the square root of 6 would be 6, but you'd now have the square root where you didn't have one before. Okay, so you're going to have to use the conjugate. You think of this as, say, a plus b. And what we do is we multiply by a minus b over a minus b. This is a plus b, so we need a minus b, the conjugate. This is a plus b, a minus b. And whatever you multiply the bottom by, of course, you must multiply the top by as well. If you look in the problem that we just worked out, we had a minus b to start with. So then we multiplied by a plus b over a plus b. On the other hand, if you have, on this board here, a plus b to start with, then you multiply by a minus b over a minus b. You always multiply by the conjugate. If you start with a plus, you multiply by the minus. If you start with the minus, you multiply by the plus. Okay, now, on the top, you must distribute the square root of 2 times through the parentheses. You have the square root of 2 times the square root of 6, and then the square root of 2 times minus 2, so minus 2 times the square root of 2. And on the bottom, you have a plus b times a minus b. Okay, so you're going to get a squared minus b squared. By the way, if this is hard for you to do in your head, there's nothing wrong with doing it by the FOIL method. Okay, if you did do it by the FOIL method, you'd have the square root of 6 times the square root of 6. Outer is minus 2 the square root of 6. Inner is plus 2 the square root of 6. And the last is plus 2 times minus 2, which is minus 4. Okay? The important thing is that in the bottom, you get just square root of 6 times the square root of 6, which is 6. The outer and the inner will drop out, minus 4. Okay, that's why we've done this, because now we no longer have a radical in the denominator. In other words, if you think of this as a plus b, you multiply by a minus b over a minus b. If you can do it in your head and say, well, this is going to be a squared minus b squared, that is the square root of 6 squared, which is 6, take away 2 squared, which is 4, fine. If not, by all means, write out FOIL. But when you do it, outer and inner will cancel each other out. Okay, on the top we have the square root of 2 times the square root of 6, which is the square root of 12, minus 2 times the square root of 2. Now, we don't have this in simplest radical form yet. Let's do a little bit more work on that. We're up to this point. We have, let me just rewrite it. We have the square root of 12 minus 2 times the square root of 2 over 6 minus 4. Now, square root of 12, well, this is not in simplest radical form. We can make this square root of 4 times 3 minus 2 times the square root of 2 over 6 minus 4, which is 2. And we have here the square root of 4 times 3 can be written as the square root of 4 times the square root of 3 minus 2 times the square root of 2 over 2. The square root of 4 is 2. You get 2 times the square root of 3 minus 2 times the square root of 2 over 2. And we're almost finished. All we have to do is realize that in the numerator we can't factor out a 2, giving us 2 times the square root of 3 minus the square root of 2 over 2. And in doing this, okay, the 2's will cancel. The top, we factored out a 2, which will cancel the 2 in the denominator, giving us a final answer of the square root of 3 minus the square root of 2. And this brings us to the end of the tape.